Hi everyone! Today we're going to be talking about complex fractions. So our objective for today is that students will be able to simplify complex fractions. Let's get started. Alright, so first of all, what is a complex fraction? A complex fraction is a fraction in which the numerator and the denominator, so the top and the bottom, both contain fractions. To simplify a complex fraction means to rewrite it as a single fraction with no fractions in the numerator or denominator. So the steps to simplify complex fractions, how do we do this? First, you want to create a single fraction in the numerator and the denominator. So if you need them to have common bases, make them have common bases, combine them together. Then set it up as a division problem and multiply by the reciprocal. Last but not least, simplify using exponent rules and any other factoring strategies that we can. Alright, always factor first if possible. Let's go through a couple examples on how to do this. Alright, so number one. First thing we want to do is make sure we have single fractions in the numerator and the denominator. So we look at our numerator, single fraction. Look at our denominator, single fraction. So now we can move on to step number two. Now we want to set it up as a division problem. So we want to rewrite this as a division problem. So what this is it's a over 2 divided by a squared minus 4. Now this looks a lot easier to solve. Now when we've got two fractions or two rational expressions, we're dividing. Next thing we want to do is copy, change, change. Copy the first one, change the sign to multiplication, flip the second one. Okay, so we're going to copy a over 2, change it to multiplication, flip our second fraction, or second rational expression. Now we're just multiplying straight across. Multiply the numerators together, we get 4a. Multiply the denominators together, we get 2a squared. Now we just want to simplify, alright? So 4 divided top and bottom by 2, we get nothing, we get 1 and 2. A cancels out here, we're left with a single a on the bottom. So our final answer is 2 over a. And you're done. Alright, number 3, we've got a single fraction in the numerator and a single fraction in the denominator. So the first thing we want to do here is set it up as a division problem. Rewrite it as a division problem. So you've got 18p over 8p minus 2 divided by 4p squared over 4p minus 1. Now we want to copy, change, change. Copy the first one. Change the sign to multiplication. Multiply by the reciprocal. So flip the second one. Alright. Now, in order to simplify, we want to factor out what we can. So we can factor out a 2 here on the bottom. So we get 2 times 4p minus 1. 18p stays on the top, times 4p minus 1 over 4p squared. Now, common binomial factors cancel each other out. Alright, 18p and 4p squared. We can divide both of these by 2. So we're left with 9 and 2. This p and one of these p's will cancel out, so you're just left with 2p here. Now we want to rewrite what's left. So on the top we've got 9, and we've just got our single 9, and on the bottom we've got 2, 2, and p. So 2 times 2 gives us 4 and a single p. And that's our final answer. Alright, so I want you to try to do number 5 all on your own. Alright, so remember, make sure it's a single fraction in the numerator and denominator. Rewrite it as a division problem. Then multiply by the reciprocal and simplify what's left. Alright, so go ahead and try to do number 5 on your own. When you come back, I'll have the answer written on your screen and we will go through it. So go ahead and pause your video now. Alright, so the first thing you should have done was rewrite it as a division problem. So we've got 7c plus 35 divided by c divided by c plus 5 over c squared. Then copy the first one, change the sign to multiplication, flip the second one. Alright, Then we want to factor out 7c plus 35. Take out a 7. So you're left with 7 times c plus 5. All right, remember when we're simplifying, first thing we always do is factor if we can. Then the c plus 5 will cancel out. Here we've got a c and a c squared. So 1c and 1c will cancel out. We're left with 1. We have 1c left over. So what's left is 7 here, c here. Everything else is canceled out, so our final answer is 7c. All right, number 7. So if you see a problem that looks like this, all right, we've got a fraction in our numerator, and we've just got a binomial expression in our denominator. This is considered a complex fraction as well. The 12r minus 12 can be written as 12r minus 12 over 1, and then we just treat it like a complex fraction. So then we want to rewrite it as a division problem. So 15 minus 15r over 15r squared divided by 12r minus 12 over 1. Then we want to change it to multiplication, flip the second fraction, all right, or the second rational expression. So copy, change, change. Copy the first one, 15 minus 15r over 15r squared. Change to multiplication, flip the second rational expression. Now, factor out what we can factor out. So, on top here, we can factor out a 15. So, 15, we get 1 minus r. And then we've got 15r squared here. Times 1 over, factor out a 12. And we've got r minus 1 here. Now, remember our rule when we have a minus b, b minus a, right? When we've got a minus b over b minus a. That's what we have here, 1 minus r minus 1. This is going to simplify to negative 1. So these will cancel out and we're left with a negative 1. Now we can cancel out the 15 and 15. Those will simplify to 1. And we're left with, all right, if we move this up, on top we're left with a negative 1. And that's it, negative 1 and positive 1, so you get negative 1. On the bottom, we're left with our r squared and our 12. So our final answer is going to be negative 1 over 12r squared. And you're done. All right, moving on to number 9. So number 9 is where we first need to make it a single rational expression in both our numerator and denominator. So we need a single fraction in our numerator here. Okay, so right now we have x minus 3, or x over 3 minus 3 over x. This is not a single fraction. So we need to combine them together. And in order to do that, they need to have common denominators. So the first thing we're going to do is subtract these fractions and make them have common denominators. So the LCM here of 3 and x would be 3x. So multiply the top and the bottom here by x. Multiply the top and the bottom here by 3. So you're left with x squared over 3x minus 9 over 3x. All over x minus 3 over x. Now we've got common denominators, so combine the numerators together. We get x squared minus 9 over 3x all over x minus 3 over x. Now we have a single fraction in the numerator, single fraction in the denominator. So now we want to rewrite this as a division problem. X squared minus 9 over 3x divided by x minus 3 over x. Now we're just simplifying, so I'm going to scoot everything up. All right, so now copy, change, change. Now it's just a division problem, okay? So now we change it to multiplication, flip the second one, factor out our x squared minus 9, difference of squares, so we get x plus 3, x minus 3. All right, oops, let me scoot everything up. All over 3x times x over x minus 3. Now we've got x minus 3, these will cancel out. Our x and our x will cancel out, and we're left with x plus 3 on top and 3 on the bottom. And that's our final answer. Alright, so now this next problem, I know on your paper it says 15. It's really number 11 if you look at the order of the rest of the problems. I'm sorry, mistake. Alright, so this is number 11. Let's do number 11 together. Alright, so single fraction on top, we're good. Alright, but on the bottom, we do not have a single fraction. So we need to make it a single fraction, and we need to subtract and combine our like terms. So first thing we want to do is factor out a 4 here, and we get 4 times n minus 4. Alright, so that's this denominator. Now in order to make this denominator the same, we need to multiply it by 4, and whenever we multiply the bottom by, we have to multiply the top by. So for number 11, we've got 5 over 4 on top, all over. 4 times 20 gives us 80 over 4 n minus 4, minus 5 over 4 n minus 4. Now they're common denominators, so we can just multiply or subtract, alright? So we get 5 over 4 divided by 75 over 4 n minus 4. Now we've got a single fraction in the numerator, single fraction in the denominator, so now we just want to rewrite this as a division problem. 5 over 4 divided by 75 over 4 n minus 4. Okay, then we want to copy, change, change. Copy the first one, 5 over 4, change it to multiplication, flip the second fraction. Then we want to simplify. Alright, so if we cross simplify, 5 divided by 5 gives you 1, 75 divided by 5 gives you 15. These 4's will cancel out, and we're left with n minus 4 on top, 15 on the bottom. So our final answer is n minus 4 over 15. And you're done. Alright, number 13. Do not be intimidated by this, okay? I know we don't have a single fraction in the numerator or a single fraction in the denominator, but we can easily make them have common bases. Alright, so for number 13, we've got a squared, 1 over a squared minus 1 over b squared. In order to make them have common bases, simply multiply top and the bottom by b squared over here, top and the bottom by a squared over here. Alright, so then we would have 1 times b squared gives you b squared over a squared times b squared minus 1 times a squared gives you a squared over a squared b squared. Okay, now over here in our denominator, we've got 1 over b plus 1 over a. Same idea, multiply the top and the bottom by a over here, multiply the top and the bottom by b over here. So then we've got 1 times a gives us a over ab, plus 1 times b gives you b over ab. Now, start with the top. We've got common denominators, so then it's just b squared minus a squared. And we've got b squared minus a squared all over common denominator, a squared times b squared. All over. Now down here, we've got a plus b over ab. Now we've got a single fraction in the numerator, a single fraction in the denominator. So now we want to rewrite it as a division problem, okay? So rewrite it as b squared minus a squared over a squared b squared divided by a plus b over ab. Alright, now copy, change, change, alright, because we can't divide fractions. So copy the first one, b squared minus a squared over a squared b squared. Change it to multiplication. Flip the second one. Alright, so now we've rewritten it as a single fraction. Alright, we've rewritten them as single fractions, rewrote it as a division problem, copy, change, change, Now we want to factor, all right? So if we're looking at this right here, we've got difference of squares. This is our first one, this is our second one. So we can factor this out and say b minus a, b plus a, okay? Over a squared, b squared, times ab over a plus b. Now, remember, we've got b plus a over a plus b. Anytime we've got b plus a over a plus b, or a plus b over b plus a, okay, this equals 1. Okay, so these will cancel out and equal positive 1. All right, because order doesn't matter. We just switch them around and they're exactly the same thing. Now, ab and a squared, b squared, ab will cancel out, and the squareds will cancel out, so we're just left with ab on the bottom. Now, if we want to rewrite all this, let's see, screwed everything up. Rewrite this. What's left? We've got b minus a, we've got a 1 on top, we've got a, b on the bottom, and that's it. So we've got b minus a over ab, and that's your final answer. All right, if this was a little confusing to you, if you have any questions, please, please, please raise your hand, call me over so I can help you. Otherwise, let's move on to our last example. All right, last but not least, number 15, and this is actually number 15 this time. All right, so first thing we want to do, make them have a single fraction in the numerator and the denominator. So the LCM of the top would be 4v, so all we need to do is multiply this side by v over v. Then if we're looking at the bottom, common denominator would be 4v as well, but we need to multiply the top and the bottom over here by 4, top and the bottom by v over here. Now let's rewrite this so they have common denominators. We've got v over 4v plus 1 over 4v all over 4 over 4v plus v over 4v. Now combine the numerators together and we get v plus 1 over 4v all over 4 plus v over 4v. Now we've got a single fraction in the numerator, single fraction in the denominator. So take this and rewrite it as a division problem. V plus 1 over 4v divided by 4 plus v over 4v. Copy, change, multiply by the reciprocal. V plus 1 over 4v times 4v over 4 plus v. 4v and 4v will cancel out. And what you're left with is v plus 1 on top, 4 plus v on the bottom. And that's your final simplified answer. Alright, so I hope you learned a thing or two about complex fractions today. Remember, if you have questions, call me over so I can help you. Otherwise, look to the teacher or look to the board to see what to do next, and I hope that you have a great day.